This meeting is being recorded.
रसोई में छिलके पड़े, फलों के साथ गुड़ भी भरे, पानी मिलाओ समय दो यार, प्रकृति का जादू है चमत्कार। बायोएंजाइम चमकने दो, हर बूंद से धरती को साफ करो, फर्श से लेकर बाथरूम तक, जूते भी चमके है कमाल ये सब। ना जहरीला ब्लीच न सपड़े का डर, नींबू सा प्यार करे असर, कचरे से चमत्कार की ये कुंजी, साफ सुथरी बिना केमिकल की दुनिया बमसी। 30 दिन तक आते रहो, बुलबुले देखो जादू कहो, कंपोस्ट की ताकत इस बोतल में, घर बदले नियम भी बदले क्षण में। बायोएंजाइम चमकने दो, हर बूंद से धरती को साफ करो, कपड़ों नालियों बगीचों के लिए, साफ सुथरी दुनिया शुक्रिया तुम्हारे लिए। छिलकों को अब ना फेंको यार, कचरे से बनाओ सुनहरा उपहार, हर मिश्र में है एक संदेश, हरियाली दिल स्वच्छ भूमि विशेष। बायोएंजाइम अब वक्त है चमकने का।
Okay, so a very happy new year to all of you and welcome to BEAT 2026. I'm Samira Satija and I'll be serving as your moderator for today's session. BEAT 2026 is a month-long global awareness and action campaign for toxin-free living and environmental regeneration. To do so, we'll be conducting expert talk series, open dialogue, trainings, and hands-on workshop across India. This initiative aims to empower citizens, communities, and institutions to rethink everyday habits which impact human health, water, soil, and air. It is also a celebration of World Bioenzyme Day that we observe on 4th January, and we will be dedicating this whole month to deliberate upon the potential of bioenzyme in various fields. So each day we'll be highlighting one commercial household product that is toxic in nature and harm our homes. And each day we'll be showcasing a safer, natural, and enzyme-based alternative to that particular product. So as humans, we usually are more concerned about our homes, our household products, and indoor environment. But we cannot ignore the bigger problem and greater damage being done to our water bodies and other natural assets through our own bad habits. There's enough data on paper, visual proofs through social media and other platforms about the sad status of our rivers, broken waste disposal system, poor handling, and ineffective water and waste management. We are also well aware of the fact that how dysfunctional and inadequate STPs, ETPs are killing the rivers, ponds, water channels, and the freshwater bodies. So during these 3 days long talk series, we'll be exploring the potential of BE and to see whether bioenzyme can be a part of the solution. Topic of today's talk is sludge management, and I'm very happy and elated to inform you that we have very accomplished and experienced subject experts with us who will be sharing their learnings and help us to understand the myths, the realities, the limitations, and the possibilities. Before we proceed further, let's collect our thoughts to invoke universal powers and ask for wisdom, harmony, prosperity, and peace. May I request Ms. Sucheta to recite the Shanti Path?
नमस्कार. ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विना वधीतमस्तु मा विद्विषावहै. ॐ शान्तिः शान्तिः शान्तिः. Thank you.
Thanks, Sucheta. Now, to open out the event formally, may I request Ms. Preeti Rao to give her inaugural note? प्रीति आप म्यूट पे हैं. प्रीति, you are on mute.
Thanks, Amira. Good evening and very warm welcome to everyone joining us today. On behalf of Bioenzyme Entrepreneurs Academy of India, it is truly a pleasure to welcome you to Beat 2026 Talk Series, part of our month-long global movement dedicated to toxin-free living and environment regeneration. January is a special month for us. BEAT is celebrated every year alongside the World Bioenzyme Day on 4th of Jan as a gesture of gratitude and respect to our mentor, Dr. Roshagon Pompawong, whose vision continues to inspire thousands across the world to reconnect with nature-based solutions. Over the next 3 days, we will come together to reflect, question, and discuss some very real challenges: sewage treatment management, polluted river, growing landfills, and the invisible toxin entering our home, food, and water. More importantly, we will explore whether solutions like bioenzyme can play a meaningful role, where they work, where they don't, and what responsible action truly looks like. BEAT, it's Bioenzyme at Transformation. Talk series is not just about talks, it's about conversations, learning, and collective responsibility. We hope these sessions encourage you to think differently, ask difficult questions, and take small but impactful steps towards change. Thank you for being the part of this journey. Your presence here today is a statement of care for our environment and community and future generation. Thank you so much.
Thank you, Preeti. I think our distinguished guests have joined us. Please confirm me if Dr. Chandana and Dr. Arun has joined so that I can start introducing.
Yeah, I am here, Samira.
Thank you, ma'am. Thank you so much. So we have Dr. Chandana with us. Dr. Chandana is an accomplished academic and practitioner in the field of environmental engineering, currently serving as an assistant professor at the Center for Emerging Technologies for Sustainable Development, Indian Institute of Technology, Jodhpur. She brings a wealth of expertise and a deep commitment to advancing sustainable practices. Dr. Chandana earned her PhD in Environmental Engineering from the prestigious Indian Institute of Technology, Bombay. With a decade of professional experience spanning environmental issues and the information technology sector, her interdisciplinary approach addresses critical challenges in sustainability and development. Thank you so much, ma'am, for joining us. Despite not feeling well, we are truly grateful to you. Hope you are feeling better.
Thank you for the nice introduction. So, I share the screen now and we can start?
Yes, ma'am.
Yeah. Okay. I hope my screen is visible for everyone.
Yes, ma'am.
And am I audible clearly?
Yes.
Yes, ma'am.
Yeah. Thank you so much. So today I'll be talking about some insights. English is fine, or English is fine. Okay. So we'll be having a insights on sludge management and how our team is looking that bioenzyme can be helpful instead of the chemicals for the managing the sludge. Okay, so I am Chandana, as introduced. I work as an assistant professor in IT Jodhpur. So IT Jodhpur is my slides are not moving, right? Is my slides moving?
Yes, ma'am.
Okay. So, IT Jodhpur is one of the Indian institutes for Rajasthan. We believe in sustainability, not in making it as a campuses or green sustainabilities. We believe definitely from the a point of indigenous technologies and indigenous things like how bioenzyme is a natural based thing. We look into the simple sustainability aspects, natural based. We look like this in summer and also we look like this in the rainy season. So we are a institute who believes in that how the system is there and natural based things should happen. And we are proud of that. And my lab is called Sustainable Waste Management Lab, and our mission is mainly dedicated in providing cutting edge research and innovations towards mitigating the waste and human sufferings. We align with human and the waste. So this is my team, and we have few projects, and we look into different aspects of waste and sustainability. So coming to our topic today, so wastewater management, when we consider, it is divided into mainly three types, like primary, secondary, and tertiary. When these treatment happens, the secondary treatments, which are when we consider primary, tertiary treatments, secondary treatments are the, if you see the figure also, secondary treatments work mainly from the biological treatment perspective. You consider any kind of waste management or any kind of water treatment or any other aspects, main things which shows the result in real is these secondary treatments, which are mainly, if you consider any kind of degradable system, there'll be there can be aerobic, anaerobic treatments. So what happens is that basically if you consider aerobic treatment, these the oxygen consuming bacteria will try to eat the organic waste. In meanwhile, it processes the any kind of treatment. If we consider there are a lot of type of bacteria which are not visible to us, which are very helpful for the human survival. Even though we consider ourselves as the premium in the top food chain, but if anybody says that, can you imagine that there's no microorganisms and others? being scientific people, we say that no, we won't, we can't just survive just based on considering that humans are the most species which can survive. But without these bacteria, none of our waste or none of our daily things will be catered. However, how does it works? The basic ingredients or anything for considering all of the kind of treatment is that you need high density of microorganisms, good contact between organisms and waste, provide high level of oxygen is required, and favorable temperatures, pH, nutrients, and main, if you see anywhere, any person, I think the last point is mainly missed nowadays in anywhere. No toxic chemical present should be there. However, so these are kind of how does these treatment happen, how the sludge comes out. This is how it looks like. Few of the examples of how the sludge comes out and how does the secondary clarifier work. The main issue now which we are facing or anywhere people are not mentioning is that whenever we consider wastewater or sludge system, nowadays they are making it as a separate systems. That okay, these in anywhere, I think it's end of the cycle process. Everybody are thinking that whatever goes out of my house is not my problem. And the issue has become that because we are mainly dependent on these bacterials to be survived because of using of chemical toxic ingredients, considering our cleaning house material or any other materials which we use in toilets or cleaning for the house, if these toxics chemicals are used in higher version, all our bacterial system fail because they are not just sanitizing our houses. It has an effect that it will directly impact the systems. You can ask that it doesn't matter if it impacts the system. The issue is that if it impacts the system, it increases the cost. It comes back to us in different aspects, economic, physical, also biological aspects, and even socio-economic aspects. All these comes back. Okay, one of the issue in India which we are as a scientific people also are looking at breakdown of all the treatment systems which were well designed. And when we go back, those directly comes from these chemical cleaners or chemicals which are used. So what we did from the Bioenzyme Academy only, we got many of their bioenzymes, which we were lucky to get those bioenzymes, and we are trying to analyze how these bioenzymes can be used and how efficient they are in the improving any kind of treatment systems. So if we consider first what we did was that time-based optimization. Here, lots of tests we have done based on different times, different the enzymes which we got. We understand how many types, what type of enzyme is efficient in for what type of treatment. We understood that. If you see that here, you can clearly see that time-based optimization for different types of enzymes we have considered. One is time based, next is concentration based. One time based is more like that. Okay, if you put a concentration of a bioenzyme, to what time it can be efficient, not efficient, it is efficient in the minute you apply, but 100% what time is the efficient. If you see the graphs, you can clearly see that based on different types, different timings, and different types of contaminants we are looking, we are finding different types of time-based enzyme activity, whereas concentration-based, we found that different types of bioenzyme work at different concentration, not much different, but if you see 10 power minus 8, if we use 10 power minus 8 means if you take 1 ml of bioenzyme and if you put it into more than 8, like if you take not 1 ml, if you take 10 ml and you put in 100 ml, then that is efficient for the uh, removal of different TDS, EC and all. Mainly basic parameters can be removed, pH, EC, or all that can be removed in 10 power minus 8 concentration for one type of bioenzyme. And the same way, if we consider for the other type of bioenzyme, we told that we got many types of concentration. The concentration based also is changing. You can clearly see here that the different types of bioenzyme and different types of concentration, it works better. That small optimizations we have done. Then we understood that different for total solids or for total suspended solids or total dissolved solids, how much is the concentrations levels which are decreasing. And you can see in the central graph that if the neem-based solutions are there, then the pH remains almost little, pH was reduced a lot, whereas other type of wastewater, if we analyzed and all, there was a very much removal efficiency and it was bringing back the normal concentration. The same thing was found for total solids and suspended solids and other thing. Same thing was found for electronic conductivity. These are some parameters which we look into when we do the scientific analysis. And then we did the ionic concentration. The mainly when we say that bioenzymes are working and all, the proof of how it's working matters a lot. So we understood that alkalinity, acidity, hardness, how is it how is it getting removed when we add which type of bioenzyme. And basically we already made sure that what is the time and concentration optimization, which led to us to understand the reduction in the overall point is that when we use the bioenzyme, we were getting very good results in the removal of all alkalinity, acidity and hardness also. Same way we did for metal analysis. Metal analysis, we found that few metals were becoming almost zero, or it's mainly, you can ask me that bioenzyme is removing. No, bioenzyme is making sure that these metals get settled down so that the water or the sludge can be pure. Same way, organic loading, COD, BOD, we checked. There was a very good reduction in the concentrations from the bioenzyme. This is was like for one loading, for one time, for one concentration, this was found. If we do the repeated test, there was a very in one go only we found so much good results. Same way we did the bioactivity assessment. Why is this bioenzymes good? Then we understood that they have mainly protease activity, which is very necessary for the removal of the any kind of contaminate, and also we have it has an anase activity and also lipase activity was there. So these three are very good and it's available in these bioenzymes. And we also understood that pathogen removal efficiency. When we say that chemicals are the better things to remove bacteria or any kind of, that's why we should use chemicals. We found in our study that these bioenzymes can also remove pathogens. So when they remove pathogens means these are much better and can be used for in our household instead of the chemicals which we use. And you can clearly see that this is the blank which says the A, whereas B is where we found the pathogens, the red color dots and all are the pathogen. And when we used bioenzyme one time, you can see that there is pathogen reduction. Same way for the these things also. finally, when we saw the bioenzyme activity as an overall, the main concept is that it has all it does not work. It's not like something magic or something. It has activities which is happening. These natural activities are accelerated in these bioenzymes by hydrolysis or biodegradation. Even oxidation reduction happens. The first step is like, if you say first oxidation reduction happens, then flocculation and absorption happens, and then comes the ionic exchange and complexation happens. Then pore entrapment and biofilm formation happen. And finally, pH buffering and nutrition cycling happens. Then finally, hydrolysis and biodegradation happen. All these activities happen based on the enzyme activities which is present in the bioenzyme. So this is the final results and proofs which we found that bioenzymes does work as much better agents and can be used for the sludge management instead of always using these chemical agents, which also turns into becoming like a more emerging contaminants. It's becoming like one problem we are trying to solve immediately and trying to make these chemicals stays like forever chemicals if we keep on using these. And India is becoming one of the most cancer prone areas also. If we continue to do this, our lifespan reduces and everything else reduces. But the same way, bioenzymes, if we see, naturally it is acting and naturally it is making sure that everything is being removed. And also when we say, okay, bioenzyme, people say that, okay, what if we use bioenzyme in large scale? Do you have the proofs and all? So we did technical assessments on if we use bioenzyme, how positive it is, how. So we found that total cost reduction and operational production cost comparison also we found, and also we found environmental impact also. And finally we saw that bioenzymes, which mainly made every bioenzyme found very good only, but if we use bioenzyme, banana based bioenzyme, neem based bioenzyme and all, we get a good sustainability ranking for that. So thank you so much for the opportunity. So we are looking for collaborations anytime, any type of that. You can take note of our lab and details. And if you just type Chandana N IT Jodhpur, you will get online also our details. Thank you so much. Any doubts or questions?
Thank you so much, Chandana ma'am. And yes, we have some 5-7 minutes, so we can open the floor for people to ask question. I had some question, but yeah, you had already addressed all of them. So I'll open the floor for our participants to ask if they have any doubt. I had some questions, but yeah, you have already addressed all those questions. Although one question I have, ma'am, do you think that bioenzyme or the nature-based solutions have the potential or the capacity to address very harmful contaminants like PFAS? I have been hearing PFAS quite a lot, and honestly, I have been very fearful of this chemical because this is called a forever chemical. And I mean, do you have any association by on working with this chemical, or maybe do you have any study which you have come across and found that yeah, nature-based solution can work on these kind of contaminants also?
Yeah, thank you, Samira. It's a nice question, and everybody are worried about PFAS. The issue is that PFAS are simply chemicals which are there everyday based in our life. So one type of solution is that if we stop using these chemicals in our household and start using the bioenzymes which are natural based, 50% of the load on creation of PFAS will be removed. PFAS are more complex chemicals, and as it told is also, it's forever chemicals because it's in 1 gram, if you add into the 1,000 liter of water, it does not have an effect. And if that 1 grams becomes like 1,000 grams, because of we continuously use these chemicals for cleaning, considering like I don't want to name any chemical which we use continuously in the household. For us, it became something like my bathroom has to look very clean, and we use so many chemicals, and it those becomes PFAS or any kind of forever chemicals. So to avoid that, first thing is we definitely has to stop using the chemicals so much. Second aspect is yes, one of my PhD is looking into that if bioenzyme can directly remove the forever chemicals. So we are still yet doing the studies.
Thank you so much. It's such a relief to hear that. So any more questions from the audience?
Hi, Ms. Chandana, and thank you, Samira ji, for the opportunity. My name is Preeti, and I co-run a company called Smaller Footprints, which is into sustainability awareness. So my question was the application and the results which you shared. Is it like the research paper is also available publicly for or is it like a limited research which you have shared for this audience?
Yes, Preeti, we are almost getting it finalized. It's under review. So once it's publishes, we'll definitely share with the committee.
Sure.
Yeah.
And can I also know what's the duration of this study? Like,
It is conducted on continuously 2 year samples.
oh wow,
2 years samples collected. So it has a huge duration to consider, not one time study.
oh, wonderful. Great work you all are there. Thank you so much.
Thank you.
Any other question from the audience?
Yeah, I have a question.
Yeah.
So, considering your research, can you just summarize in couple of lines for a layman that, in general, like which enzyme you think is best in what concentrations till now? Which one you found like in what concentration it was used and it was effective, like in very short, maybe to summarize this.
So we found that's the issue. Like we found neem and all were much better in 10 power minus 8 concentration for removal of pathogen and all. Neem based and even we all know banana based, these things were good in 10 power minus 8. But everything else worked good. It differed with the concentrations, that's all.
So all work more or less equally well, depending on
Yes.
concentration.
Yes.
Okay, thank you.
Thank you.
Could I ask a question here, please? My name is Swarna.
Yes, Varna.
Please go ahead. Yeah.
I was wondering, so all the studies being done on, I'm guessing, secondary waste, what, would there be research which would be on regular water, especially given the manner of RO and everything that we use? Is there any way that would look at bioenzyme coming in as a solution for drinking water, regular potable water?
Yes, Varna, thank you. So in this study, which just showed on sludge management, but we are also looking into normal water bodies. We are from Rajasthan, so we have traditional water bodies. So we are continuously verifying if bioenzyme can work for the water treatment. Till from 2 years, our studies shown that it is working much better for water because wastewater has more concentration. So water, it is showing very quick and good results.
That's interesting to know. hopefully soon we will get rid of ROs in all our homes.
Yeah, hopefully. Yeah.
Thank you so much.
Thank you so much.
All the best for all your study.
Thank you. Thank you.
Bhavarji,
I have a question.
yeah,
I
Bhavarji,
have a question. I am Anil
sir,
Kapoor.
okay, sir, you go ahead. Okay.
Yes, sir.
I am Anil Kapoor from Delhi. I have a question whether we should call it as a bioenzyme or bioculture.
Name doesn't matter to us.
No,
It has
because
enzymes.
enzymes are drawn from the living organism, and
Eh,
bioenzyme is from the green vegetables and all. This difference we have to understand. Otherwise, the court has got lot of questions over this.
Okay, okay. So we are
We
fine
should
with
use
this.
the appropriate word.
So instead, bioculture has a bigger umbrella.
Bioculture is drawn from all green vegetables, fruits, and other things. And enzymes are made from the fish, egg, and other things. So this hairline difference we have to understand.
I'm fine,
I
sir.
was I was one of the person who was very lucky enough to stay with Dr. Usukon for 7 days in Thailand.
Okay. I accept, sir. Any name is fine for me.
This
We are
this
just
hairline
looking
difference
at
I have
this
to
a
be.
treatment system, that's all.
Okay, so we have Bhavarlal ji. Bhavarlal ji, आप क्वेश्चन पूछ लीजिए मैम से.
मैम नमस्ते.
नमस्ते, ma'am.
जोधपुर के पास से मैम चंदा मैम नमस्ते, बालोतरा से बोल रहा हूँ.
हाँ, नमस्ते जी.
मैडम अभी जो ये पॉल्यूशन वाली जो इंडस्ट्रीज में प्रॉब्लम आ रही है, अपने आपको पता होगा जोधपुर में भी
हाँ, हाँ.
और जो लूनी नदी और है, इसमें जो हमारा जो कपड़ा आता है जो महाराष्ट्र से, इसमें जो ये स्टार्च और जो मॉडिफाइड स्टार्च है और पीवीए जिसको ये पॉलीविनाइल अल्कोहल कहते हैं, इसमें अपना बायो एंजाइम कुछ वर्किंग कर सकता है या किसमें कोई आपने कोई एक्सपेरिमेंट किया हो?
अभी तक तो मैंने उसके ऊपर नहीं किया है, लेकिन शायद कर सकते हैं बिकॉज इट वर्क्स ऑन बेसिक प्रिंसिपल. तो
ऐसे में
अभी
राकेश जी सर को सैंपल भिजवाए हैं. आज ही
ओके,
मेरी उनसे बात हुई थी तो मैंने कहा था आपका ही बोला था.
ओके.
मैम वहाँ पर काम भी कर रहे हैं तो थोड़ा आप उनसे कनेक्ट करके इसमें कुछ यदि हो पाए
हाँ,
तो
हाँ.
अपने थोड़ा इसमें देखना होगा.
ठीक है, आप
अभी तक
हमसे कनेक्ट कर सकते हैं, बाद में हम कनेक्ट करके आप देख
ऐसे मेरे को
लेंगे.
टेक्निकल नॉलेज नहीं, मैंने सैंपल नागेश जी सर को भिजवाए थे यहाँ के
ठीक
जो
है,
वेस्ट वाटर के.
ठीक है.
मैं वो
अब
स्टार्ट
अपन लोग
काम नहीं हुआ ना अपना.
अपन लोग जॉइंट वो कर लेंगे, इसमें एमओयू जैसा कर लेंगे और फिर
ओके
उसको आगे लेके जाते हैं. एंजाइम एकेडमी और जोधपुर आईआईटी के साथ वैसे भी ऑलरेडी उनका टाई अप है अपना, तो अपन इसको ये जो सेपरेट प्रॉब्लम को सेपरेट तरीके से हैंडल कर लेंगे.
ओके ओके थैंक यू सर. धन्यवाद मैम.
थैंक यू सो मच.
Okay. So, thank you so much, Dr. Chandana, for this wonderful, wonderful case study you have shared with us. And it's actually very hopeful. It is sounding very hopeful that, I mean, if we start reducing the chemical products from home, so at least the 50% battle is won. That's what I understood from the problem, that if you are struggling with management of something, just reduce that thing so the management will be easier. So thank you so much. Please accept our heartfelt thanks for joining with us. I hope you didn't overexert yourself and we wish you a speedy recovery. Thank you so much, Dr. Chandana.
Thank you so much. Thank you for the opportunity. Thank you.
Can you please confirm, admin team, can the Dr. Arun had joined us?
Yes, Dr. Arun is available.
Okay. So our next speaker is Dr. Arun. Welcome, Dr. Arun. Dr. Arun is a research scholar and specializes in bioenzymes. His research work includes investigation of the characterization, production, and optimization of garbage enzyme produced from pre-consumer organic waste. and subsequently identify the effect on anaerobic digestion of dairy waste activated sludge. Dr. Arun studied industrial biotechnology at PREC Thanjavur and environmental science and technology, Department of Chemical Engineering at AC Tech, Anna University, Chennai, and worked as environmental consultant. His contribution in research about environmental and sustainable application of bioenzyme is commendable. Dr. Arun, thank you so much for joining us today. Despite, I got to know that you have some family issue. We deeply appreciate you making your effort to be here with us. Dr. Arun, can you just open the camera? Dr. Arun, I hope you can hear me. Back in team, please check with Dr. Arun.
So by the time Dr. Arun sets up his mic or whatever, let's understand whatever is okay. He's
Okay.
not able to log in. So Dr. Arun, I'll just ask. Okay, 1 minute. So in the meanwhile, when he has fixes his mobile or the mic, so let's continue. And see, we've been talking of so much about the removal of this pollutant. So water, the elaborated research which is going on in the water sector, you can see the result, and I'm sure we have many other kind of pollutants, and I'm sure because before Dr. Chandana's work, we were still talking about so much of bioenzyme can do this, we can do this, but this work has actually proved, at least in one sector, and this is going to be a very elaborative work which is lying ahead with Dr. Chandana. And the BA is actually grateful for having her as our research partner, and she's doing so much of effort she's putting into to make things happen. And like Bhavarlal ji, she was talking about the textile problem. So हमारे एसटीपी में बहुत सारे प्रॉब्लम्स हैं सो वी आई डोंट थिंक वी नीड टू डिस्टिंग्विश लाइक ना टेक्सटाइल और any metal or agricultural waste. We need to understand the enzyme, how it is working, how enzyme is breaking down the metal, heavy metals, or biodegradable or a bio waste, or biodegradable waste, or how it is handling pathogen. So these I have left it on our scientists to figure out, but what I understand from the very basic language, these are aerobic bacteria, and it breaks down any of these pollutant in the simpler form, which can be dissolved, or it makes it as a biodegradable form. And so yeah, this is the basic thing what I have understood. And for any kind of pollutant, I mean, we've been trying out, we have done a lot of pilot projects, whether it is air pollution in Delhi or pesticides in the soil, or pesticide is form of pollutant in the soil. So whether it is a soil or it's a air or it's a water, we have been seeing the fantastic results with enzyme. It's only that we need to understand enzyme, and we need to understand the application. How do we apply it? How do we work, start working around it? And, with these kind of support from scientists, I'm seeing the research, and all of you, we are ready to take it to the public, and it has gone out from the lab, four walls of the lab. It has to be at the ground level. So, that is what we have seen. And uh, it's actually, it's a very long journey when we started addressing the grassroots cause, because we couldn't go those days to the industry and tell them, don't put this, because we don't have an answer for that. But we started talking about it to homes, every home. What are you draining out from your home? What is that which is going out from your drain, and what is that you're getting back in your tap? So, that got us to the thing of, what we are draining out and what we are getting. So that got us to what we are using it at home. And these kind of things were actually shocking. And the kind of, the beat has started with that, because every product what we use is some or the other way, it is actually creating an issue with our health or ecologically. So, that is where we need to, it just doesn't matter whether you use bioenzyme or you don't use bioenzyme, but we make sure that, the less of pollutant goes out into the source what we have. And that will help us in preserving our resources for the next generations to come. Uh, but yeah, I take enzyme as a healing kind of agent, which is healing and making things in a proper way. So basically, yeah, the aerobic bacteria, which is breaking down things and putting all the pollutant into the proper place where it should be. Because even the pollutants are the part of our ecology. We, uh, so it has not come from anywhere else, but it is supposed to be where it is supposed to be. It can't be there in our plate. It can't be there in our water. It can't be in the air what we breathe. So it has to go to the place where it is supposed to be. And that is what I think the bioenzyme is doing, putting them into the place, and Dr. Arun, are you okay now?
He's joining in 2 minutes time, Preeti.
Okay.
He has some technical issue there.
Okay. So, yeah, before he joins, let me tell our case study what we have worked in Bangalore. It's a few STPs. These are very small, decentralized STP. And we I mean, you pump in so much of money, you bring, first of all, we are draining out all the houses, which is coming out with all these chemicals, toilet cleaners, the shampoos, the dishwash, everything is getting into our STP. And then and that is actually killing the ecosystem of the sludge or the fecal matter, which is natural, which has a lot of bacteria. And then we complicate it with the chemical which is flowing from our home. Upon that, again, we add some more chemicals to treat it, and then we struggle with the sludge management if it doesn't get digested. So, it was very shocking for me to understand. Finally, the tanker, it comes, it takes out the sludge once in a year or once in 18 months, and they just go and throw it in the river. these small STPs are made so that we don't throw our sewage water into the river directly. We treat it and then we reuse it. But this is not happening. Most of the places it has been observed, and very few, I will not say 100, but very few places they are also getting into the composting and people are using it. All that is there. But most of the places, the truck comes once in 18 months or 1 year, and it takes so many hours to pump in all and then throw it. They just, and worst part is it happens in the night. They just take it so that nobody sees it. It goes, they just dump it in the river, and we are done with it. But how long can we keep doing this? And the place where we started using these enzymes in our STP, we are recovering 95% of the water, the used water. And most of the places I've seen many other STPs, the water, they recover only 5 to 10% water. 90% water is just getting drained. So, we need to understand the water also we have in a finite quantity. It is not infinite. We have the same quantity of water. It is for our food, for industry, for agriculture, for animals, for everything. So, but that is getting actually nothing is infinite here. So we all need to be responsibly handling it. So this water, which is getting cleaned here, what we are recovering 95% of the water, it is going back to the flushes at home and also in the garden. So what we have observed, when because this water is added, sewage treatment plant, we are adding enzymes. So the water which is coming out, what is getting into the garden, it doesn't smell at all. We don't find many mosquitoes. Mosquitoes have also reduced because the enzymes are there in the garden. So children are safe to play. Pets are safe to roll around, roll on the grass. So there's absolutely no challenge there. Uh, Homes, it doesn't stink. Yeah, we have seen some decoloration of water, but it doesn't stink. We are still recovering so much of water. So and this model is actually saving more than 2 lakhs liter of water in a month. And it's a small place, but yeah, we are saving so much of water. And this place, we don't even have a connection from outside, and we don't throw water outside. So there is no incoming water source. There is no outgoing water source. So we harvest our rainwater, we use our rainwater, and rainwater, and we keep recharging our groundwater. Yes, Advait.
Hi, ma'am. Thank you for sharing this experiment. I just had one question as a follow-up.
Yeah.
So when you meant you add the enzyme, is this to an already existing conventional STP, the one that runs on motors?
Yes,
And
it can be used in conventional STP as well, because we figured out, I
okay,
mean, this what we did here was a trial and error kind of thing initially. But after 2 years of successfully running this STP, we have figured out, where is the problem and where we
okay,
need to add. So here we use in three different phases. One is for desludging or digesting the
huh,
sludge, and other places we use the enzymes in different concentrations. So, the final one
okay,
has a different concentration than what is before filtering and what is there in the sludge. So, as Dr. Chandana was telling, the concentration definitely matters, and that is what we've been trying out, and it has worked. So, with a lot of trial and error and the time gap, we have figured out we need only the product what we have designed. We
huh,
need only 100 ml for 20,000 liters of water as STP water.
okay.
Yeah,
Interesting.
so
And application would be as simple as just
yeah,
flushing
just
it
pouring
down.
it. Yeah, just pouring it.
Okay. Oh,
So it's a very simple thing, and we have also done it for the kitchen, where the gray water is continuously coming out. So even there, we are, the water is getting treated and it is going to the gardens. And I
okay,
feel we
interesting.
can
No, I was,
actually solve lot of water issues when we, look into the small solutions like this. Yes. Any?
uh, I just had one more thing to ask, man. So I was at this. Can you hear me?
Yes, yeah, we can hear you.
Yeah, yeah. So I was at this restaurant, and the owner, he knows I am quite interested in waste management. So he showed me one of the products that he was using
Mm-hmm.
to reduce the sludge in his a small tank, the gray water tank.
Mm-hmm.
And he says it has been working. It has been lowering the levels of the turbidity and
Mm-hmm.
even the odor wise. But then I saw it is one of those talcum based products. So
Uh,
does that leave a residue over time, the talcum?
See, I haven't done work on that, so Advait, I won't be able to tell you.
Okay,
Yeah, so I will talk. I mean, what I have done, we can just talk about that. So, there are many
okay.
things they're using. They're using some hypochlorite kind of thing, and a lot of other things. I don't even know what are they using, but right now we we started reducing one chemical, and we saw these enzymes are working perfectly fine, and our BOD had come down to 2, which
Oh, wow.
and it is maintained at 2 to 4. It doesn't go beyond that. So it has
Nice.
definitely taken a lot of effort to optimize the use, and what also we also figured out, the age of enzyme is as important as the concentration of enzyme. So
Hmm.
the older enzymes, we saw better results. And I mean, sometimes I feel these enzymes has some kind of brain as well, because we tried, like we have sequential tanks where the water flows, and it is like it works on geographical, you know, geographically it is doing. There is no mechanic in this, and there are many tanks, sequential tank in that. So we have tried, actually, we have a time from one tank to another tank, how much time does it take. So counting that, we started putting the enzyme into it, and now then we saw, like, the day we changed from tank number 3, we said, okay, let us try in tank number 2, or let us remove tank number 3, let us go directly to tank number 5, from 1 to 5. Everything, it was reacting. I mean, people were literally pouncing on us, it is smelling, it is bad, it is this, or that. So I felt, okay, now this is what is done. We have done this, and no more experiments. We will keep these number of tanks to put our enzymes and take it. So, Dr. Arun, are you there now?
Yes, ma'am. I came.
Oh, okay, okay. So, okay.
Can you
So,
able to hear me, ma'am, now?
yes, we can hear you,
Uh,
and
Sorry for the technical issue happened, ma'am.
no problem. And thanks for joining. I know you had some emergencies in your home, but thank you for joining.
Thank
And
you, ma'am. Thank you, ma'am.
it all is yours now, and I will give
I
you
can
the
share
access.
my PPT, ma'am.
I will just give you an access, 1 minute.
Okay, ma'am.
Yes, it's all yours now, Dr. Arun.
Yes, ma'am. Thank you. Can you able to view the screen, ma'am?
Yes.
Good evening, all. So I am Arun. I have completed my PhD in NIT, and I have worked as a assistant professor. Now working as an associate professor in Periyar Institute of Science and Technology. And this institute works on majorly on sustainability, and we are working basically on how we can use the natural resources for different applications of environmental degradations. So as a part of my research in NIT, I have used garbage enzyme. I have researched on garbage enzyme and I have published nearly 5 papers on garbage enzymes. So it is basically my work is based on sludge management only. So we have started the work with the findings of how the garbage enzyme is working. So what are the basic characteristics of garbage enzyme? Because before that, some of the people have done a research on how the COD, BOD is reducing with the grey water, some domestic wastewater, sewage water, but no one have tried with sludge. So we want to know what are the basic characteristics it has. So we have done that research and we have come up with some of the nice findings also. So generally, when we start, can you able to view the slide, ma'am? I have
Only
changed the
first
slide.
screen. No, it's only first screen it is showing, Dr. Arun.
Wait, ma'am. I will. Now, ma'am.
Yeah, we can see anaerobic fermentation.
Okay, ma'am. So all over the world, the industrial sector is increasing a lot according to the needs of human beings. As a result of industrial sector, huge amount of wait, ma'am. Still, it is not connecting properly. Now the slide is changing, ma'am.
No, it's only a first slide. I think you can go to the screen. Water, we can see that.
One minute, ma'am.
Maybe he could use slideshow. Then it will
Yeah.
come.
Now it is visible, ma'am.
Yes, yes, Dr. Arun. Yes,
Okay, ma'am.
yes, Dr. Arun.
So as the introduction part, industries. Can you able to hear me, ma'am?
Yes, yes.
So industries are producing higher amount of wastewater. So these wastewaters are called as effluents. So these effluents need to be treated properly before. Ma'am, my voice is breaking.
Ah, ah,
Wait, ma'am.
Dr. Arun, if
Yes, ma'am.
possible, if you could keep one of the devices on mute, it would help.
Yes, ma'am. I
The
have
two
already
devices, I
given.
think, you have unmuted.
No, ma'am. That's why I
Yeah.
have muted in
Now your
laptop.
voice is clear, sir. Now your voice
Yes,
is
ma'am.
clear.
Yes, ma'am. So wastewater treatment. Now it is clear, ma'am. Hello.
yes, yes.
Yes, ma'am. Okay, ma'am. So wastewater treatment is generally is required to resolve or remove 3 of the solids, which are dissolved solids, suspended solids, and volatile solids. So in the primary treatment, basically they will use chemicals and physical treatment by which they will remove some of the porous solids and suspended solids, some of the suspended solids, and then they will add some of the coagulants, chemical coagulants, which will helps in reducing the suspended solids. Further, it will go to a secondary treatment where the dissolved solids to be removed. Here the anaerobic, that is aerobic or anaerobic fermentation through microbial or biological treatment have been happening. So there we will got a sludge called biosludge. In the primary treatment, whatever the sludge we are getting is chemical sludge. So generally these two sludge have the impact on disposal, and the biological sludge will have pathogens and other contaminants also. So it requires more treatment before it goes to a disposal standards, to meet the disposal standards. So further the water will be goes for tertiary treatment, policing, and finally it will be used in drinking purpose also. So it is up to the FTP what they are planned, but every FTP is producing a biological sludge, and in sewage also we are having a sludge which comes out of the sewage is a biological sludge. So these biological sludge to be treated before it goes to a to meet the environmental standard before it reaches the environment. So generally the anaerobic fermentation is a highly stabilized process for doing this process. So already so many research have been done, and the research says that hydrolysis, acidogenesis, and methanogenesis have been done with the help of some of the anaerobic microbes and aerobic microbes, which helps in producing some of the useful gas like biomethane, biohydrogen, like that. So many useful components also taken from sludge, and this is one of the best stabilizing process of sludge. So this is the idea what we have also attained. So anaerobic fermentation we want to do, but what are the disadvantages of anaerobic fermentation is, in the first step of hydrolysis process, it is a very slow process and it takes longer time to get a final product like biomethane. So we need to hydrolyze the proteins, carbohydrates, and lipids which are present in the biosludge, because biosludge is comprises of microorganism and ESP, that is extra polymeric substances. So these substances will have enzymes, microbes, and other proteins, minerals, etc., etc. So that should be carbohydrates that should be hydrolyzed. Then only the further process will happen. So this is a limiting step in anaerobic digestion. So to do this limiting step, or to make the process more effectively, so we need some of the pre-treatment process before the sludge goes to anaerobic digestion. So generally the pre-treatment are generally classified into mechanical, chemical, ultrasound assisted, thermal, biological pre-treatment. So when we are going for biological treatment, it is of two types. One is microbial, or we want to use enzymes directly. So microbes also will not degrade directly. It will start producing a enzyme. That enzyme only going to hydrolyze the components. So according to the substrate what is present, so the microorganism will produce a particular enzymes according to the substrate. As a result, that enzymes will act on the substrate and it will comes into a product or hydrolyzed product or solubilized products. So one of the major disadvantage of using enzyme, commercial enzymes, is the cost of the enzyme. So the purification process is too tedious, because the microorganism need to grow, then that should be broken off, then the enzymes will be intracellular and extracellular enzymes are there. So that should be separated, and the specific enzymes we want to purify, then it should be goes to a treatment process. So this process of producing an enzyme is so tedious. So then we want to check with some of the easiest and finest process to produce enzymes. So we have found the majorly in this anaerobic digestion hydrolysis process, hydrolytic enzymes plays an important role, which can enable the solubilization of EPS, that is extra polymeric substances, which are present in biosludge. So here the microorganism, when we are using microorganism, it also become a sludge, biosludge at the end of the process. So when we are using this enzyme, the volume reduction will be lower, and it helps in uh, um, highly hydrolyzed products or solubilized products can be produced. So the major disadvantage what we have found is only the cost of the commercial enzymes which is available. So we want to produce our enzymes. So enzyme source we have checked. So these are the criteria what we have set. So enzymes are normally extracted from microbes and plants, or these are the two major, and some of them are using animals also, but commonly it will be from microbes and plants. So we want to have an enzyme which is cheaper and faster, then we want to go for plant source. And we majorly we want extracellular enzymes like protease, amylase, lipases, which should be which is degrading proteins, lipids, and carbohydrates which are present in sludge. So then we have found some of the enzymes are found in peels of the pineapple, citrus peels, tomato peels, tomato waste. All these things we have read. Then we have found the fermentation process makes the enzymes to comes out of the waste materials also. So then we have checked with different articles and different blocks, and we have found the garbage enzyme production is some of cheapest, and it was great scientists have found, and they are using in different applications and day-to-day applications they are using like cleaning, washing, etc., etc. But no study have found whether these can be used in that field, in our field or not. So we have checked with that. So some of the research papers which is published before 2015, because I have started my research on 2012, and before 2015, what are the papers have been based on garbage enzyme we have checked, and it shows some reduction in COD and BOD level. And some of them have done, and it is having some acetic acid which is having a vinegar based concentration. So these are the major studies what I have got before starting my research. So after doing that, we started what are the basic characteristics is present in garbage enzyme. So we have done the production of garbage enzyme. So as Thailand scientists have told, we have taken 1 part, 10 parts, and 3 parts. Then fermentation was done for 3 months. Then we have centrifuged and we have filtered it, and we have went for environmental characteristics. And these are the basic characteristics we have found. So the pH level is 3.5 to 3.9, and it has BOD level is 79 milligram per liter, and COD is 158 milligram per liter, and total dissolved solids is 1040 milligram per liter, and the total protein which is present in is 42 milligram. These proteins are enzymes also comes with this total protein. So, and we have found there is no E. coli or very lesser E. coli presence within that sample. So it is having the potential of killing the pathogen have been found with this. Then we have studied for antimicrobial activity with the different fungal and bacteria, and we have found it is having antibacterial activity and disinfectant activity also. So this is how the enzymes works with sludge. So enzyme action is GE contains enzymes like amylase, protease, lipase, which digest the organic compounds like proteins, lipids, and carbohydrates in the sludge. So this helps mainly on converting protein into amino acids, then carbohydrates into smaller or simpler carbohydrates, and then fatty acids, longer chain fatty acids are unsaturated fatty acids to saturated, and free fatty acids. So these free fatty acids are the amino acids, and the simpler carbohydrates will be utilized by anaerobic fermenting microorganism to produce gas. So this is the important step what the garbage enzyme is doing, because garbage enzyme is not only an enzyme, so it is also called as bioenzyme, because according to my knowledge what we have learned, so as we are taking from peels we have given as garbage enzyme, it is given by Thailand scientist also. So then we have found some of them are using bioenzymes. So according to our knowledge, we have found bio means it is representing only on microbes, and enzymes are the catalyst which is used in the process. So it is having both microbial and enzymatic action, but we have focused only on the enzymatic action for sludge degradation. Then we have found that the garbage enzyme is highly reducing the volume of sludge by reducing total suspended solids and total volatile solids. Then we have found the nutrient release, and we have found the solubility, that is total COD is the level of organic compounds which is present in the sludge. So it is in unsolubilized form. So after the garbage enzyme treatment, it has become solubilized, and the increase in the COD level have been attained. Then we have found with the total nitrogen presence and total phosphorus which is present in the sample of sludge. Then these are the benefits which comes out of GE, using GE in sludge treatment, enhancing the compostability, because when we are going for anaerobic digestion, so the sludge will be utilized to produce a gas components, liquid and solid components. The solid components can have high organic matter, degraded solubilized organic matter, which improves the composting process, further composting process, and it improves humidification. That is, it helps for stable humic substances, increasing soil fertility, which used in sludge composting also. So this is a major part how the garbage enzyme is can be utilized for sludge treatment, and further the sludge is not going to be waste. After the treatment, it is producing some gas, and the liquid is used for some other man-use or fertilizer can be used, and the solids also after it is composting, it can be used as a manure. So this is the basic, that is, it comes under zero waste discharge when we are using a GE for sludge management. Then the overall process is cost effective when compared to other chemicals or mechanical treatment what we are using. So GE have a potential aid on environmental remediation in sludge solubilization, composting aid, and wastewater treatment also. So nowadays we have seen some of the research paper, they have highlighting it can be used in removal of heavy metals and leachate treatment, and some of them are using for a nanosynthesis process also. So and some of them are using for biocement formulation also. These enzymes have been used, that is the garbage enzyme or bioenzyme, which has microbes as well as the enzymes. So according to the application, we can optimize the enzymes or the microbes which is present in the garbage enzymes. So this is a study what we have done. So solubilization of waste activated sludge using garbage enzyme. We want to convert the sludge complex matters into simpler one. So we have taken different garbage enzyme which is produced from pineapple, tomato, orange peels, uh, cabbage, and mango, and we have found and the odor is very good for pineapple, orange, and mango peels. And when we are coming with cauliflower and tomato, the odor is not that much good. Then we have went for studying how it is reducing suspended solids, how it is increasing the solubilized COD, and how it is converting the protein into smaller amino acids, and how the reduction is happening for carbohydrate, lipids, everything we have studied for all these different garbage enzyme produced things. And we have found the enzyme level and total suspended solids. And this sludge what we have taken is only the dairy waste activated sludge. So dairy industry, effluent only we have taken. With that, we have taken the sludge from them, and we have used this study. And according to the application and according to the sludge, different enzymes will works on it. And according to ours, dairy activated sludge, pineapple and citrus have shown highest increment in sludge COD level, solubilized COD level, and the suspended solids is reduced a lot. So, and we have found when other protease, amylase, and lipase activity is more in PEP and orange peels. So, when we are going for determining the enzyme activities, we have taken protease, amylase, and lipase activity, and we have found the pH at the pH of we have adjusted the pH of the enzyme, because the natural pH of enzyme is 3.5. We have adjusted with some of the buffers we have used, and we have adjusted, and we have studied that the garbage enzyme activity of protease is about 6.5 pH. It is more in all the samples what we have taken previously, PEG, TEG, OEG, CEG, and MEG. And in the same way for lipase, it is around 8, it is optimized, and it is higher, and amylase activity is around 6.5. We got the highest activity, and with this conditions we have found the organic acids which is present in it, and we have found at the month of third month, previously it was citric acid, all these common acids are present in the starting stage, and when it goes to an end, most of the acids are converted into acetic, and we have found the acetic acid is more at the month of 3 in the garbage solution, garbage enzyme solution. Then these are the basic characteristics what we have done to study whether the garbage enzyme is working with the dairy waste activity sludge or not. So pH is this is a basic raw sludge characterization we have done. So when comparing to the total COD level, it is start COD level is start increasing with the help of solubilization process, and the total COD is managed, and unsolubilized is converted into solubilized form after anaerobic digestion, which is favorable for anaerobic digestion to produce a biogas. So the reduction of solids have been studied at different concentration for all the enzymes, and we have found some of the concentration is very higher, and we have found 15 percentage of garbage enzyme from all the peels. We have found it is higher, and the same way it is higher for suspended solids removal also. And these are the pH range characteristics of every enzymes what we have produced for sludge degradation process. And we have found the pineapple and orange has shown highest reduction when compared to other enzymes which we have produced, but it is also having an effect according to the concentration and the level what we have maintained. PEP and orange shows higher, pineapple and orange shows higher reduction rate. And we have went for analytic statistical study, and the major parameters should be checked with this study is pH, temperature, agitation and fermentation time. So we have found the pH of 36 and agitation is 200, and the fermentation time for 3. And we have found the garbage enzyme production is higher for amylase, lipase and proteases in pineapple and orange peels. Then we have went for treatment to determine the effectiveness of the treatment process. We have checked with increasing in XCOD and SS reduction, and we have found pineapple and orange shows higher increase in SCOD and suspended solid reduction. So this is the major conclusion what we have come across with the study. So we have different concentration dosage, 35 ml per liter of GE, that is pineapple and orange peels we have taken, and it shows the highest reduction of suspended solids 27.45 percentage, and increase in SCOD is around 28.36 percentage, and the proteins and the suspended solids reduction is around this milligram per liter. So and we have found the SS reduction and COD solubilization process with this optimized condition, and we have found around at the 30th hour of treatment, we have come up with the 25% reduction in SS and 28% in 28% of solubilized COD was increased. So then to increase this process more, we have used ultrasound also. So this ultrasound helps in degrading the chemicals. After GE process, we have used this, and we have found the biogas production using both the system is higher, and GE is having higher when compared with the control. So it has the ability to solubilize the sludge, and it is a effective pre-treatment methods what we have concluded from this. What we have done with this, we have concluded GE has the sludge solubilizing capability. So then this is the mechanism what we have exposed. So we have taken EPS, that is base activated sludge. So it will have a EPS complex. That EPS complex should be break off then only it will start releasing proteins, carbohydrates, everything. So that can be done with the help of garbage enzymes. So garbage enzyme helping in breaking up the EPS and the proteins which are present, carbohydrate, lipids have been hydrolyzed. To further increasing the process, we have used ultrasound pre-treatment also, because we need quantum of gas should be produced. To increase the process, we have add ultrasound also. Then we went for anaerobic digestion, and we have found that the biogasification have been produced, that is biohydrogen can be produced with the help of this process. It is increased when compared with the control, that is without any treatment. We have checked, and with the treatment of GE and with the treatment of GE and ultrasound, when using both the system, the production of gas is more. So these are the recent papers which have been cited for the sludge degradation and landfill leachate, what I have read. So this is the reference I will share with you. So the research opportunities of GE, other than sludge management, we can use, as so many people are using doing this process, soap and spray manufacturing, disinfectant manufacturing, paper recycling, wound healing patches can be produced with this. But we need to do the process very hygienically, and it can be used as a food, and it can be used in packing materials also, sustainable packing material and nano material for formulation. And now they are working on biocement, that is microbial induced calcium carbonate precipitation method. So here the urease enzymes plays an important role, and some of the people have found GE is having cellulase, urease, and some other enzymes also. But we need to optimize, and we want to find the particular raw material what we are going to use. So that is the importance about different applications. So when we are going for different application, according to the application, we want to choose the GE, that is garbage enzyme, and their raw material, that is pre-consumer organic waste, what we are going to use. So all these things helps in sustainable goal, to attain the sustainable goal. Thank you very much for the opportunity given. So any queries you can be asking.
Thank you so much, Dr. Arun, and the floor is open for the audience. If you have any query. Again, I had some queries, but Doctor, you have already answered that query. So I was about to ask you about the biogas. It's the application of
Tell
bioenzyme
ma'am.
and its impact on biogas generation and dewaterability of the sludge. But you have already answered it, so my question is settled. But audience, if you have some more questions, please. And also, I had another question, that what are the next steps in this research area, or what future studies would you recommend based on your
That's
findings?
only
You
ma'am.
have already
Continuous.
answered that. Yeah. But
Actually,
yeah, if you
we
can.
want to go for a continuous production of garbage enzyme, and it is taking 3 months of time to get fully as a vinegar or any other product which is used in different application. But when we are doing a research, and when we want to go for continuous or semi-continuous process, the time bounding also can be reduced, and the applications also, according to the application, the time of producing the garbage enzyme and the enzymes which are present within it can be identified. So we need to do a lot of research in every applications, what I have shown in the last slide.
Yes, sir. Yes, sir. Yes, sir. So, any more questions from the audience? Please go ahead.
And so many people are working nowadays. When I started, there is no papers for referring also. Now so many people have started working, and they are come up with this, nice papers also, which help to support the applications also. So by which we can able to grow a lot.
Yes, absolutely, sir. Yeah, there's a question.
Yeah, it is not the question, but yeah, I just
Yes,
wanted
ma'am.
to acknowledge your contribution, Dr. Arun. And,
Yes, ma'am.
based on your paper, based on whatever research, early research we had, we have done a lot of applications. We have done some disinfectant spray during COVID, just based on your paper, and, we could do that. And we have also treated some leachate water,
Yes, ma'am.
the landfill. It's on the ground, so it is not in the lab. And we could
Yes,
convert
ma'am.
the entire leachate water into irrigation quality water. That was actually amazing. And finally, what we came out, I mean, it was like a big pond of leachate water, and
Yes, ma'am.
we converted whole thing into irrigation quality, and making enzyme and spraying it in the landfill. This leachate pond was next to the landfill. Now we were just thinking, what if we start using the water in the pond, that leachate water itself, for treating the landfill, for spraying
Okay.
enzyme? If we convert the entire pond as
Because it is having good microorganisms
yes,
which can be utilizing the organic compounds which is available in the waste.
yeah,
So we are giving a good microorganism to the water. So it
yes.
was multiplying when the substrate reaches it.
Yes. And that
That's it.
was the idea, because for every time you have to spray on landfill, you have to bring tankers and, spray
Mm.
fire brigade to spray those water
So,
and
but it
enzyme.
should be naturally done. It takes some time to become,
Yeah.
because it is having heavy metals also.
Yes. Yes.
Leachate will have heavy metals and some of
Yes.
the toxic chemicals what we are using in cosmetics, everything.
Mm. So
So
it
that
took
should not,
us.
that cannot be degraded.
Mhm.
Uh, that
Yeah.
cannot be degraded directly by the microbes which is found till date, which is present in the garbage enzyme. But
Yes.
when the enzyme, when it reacts with, because the resistivity is a natural phenomenon of every microorganism. When
Mm.
it starts growing, it want to grow there, means it need the food which should be taken. The chemical also can be converted into their forms and they will start utilizing it. But it is a natural process, it will happen one day.
Yes,
Yes,
actually,
yes,
it did take us 8 solid months to get that result of that water.
yes, ma'am,
And
yes, ma'am.
surprisingly, I mean, I was amazed by this power of enzyme. It just took us 10 days to see some crawlies in that heavy metallic polluted water, leach it.
Okay.
So we were
Then
very
it
happy to,
starts
yes.
growing.
Yeah, so we were really happy to see those, life flowing in that dead water. So we
Yes,
knew it
ma'am.
is getting treated. It took really long time,
Yes,
but
ma'am. Yes,
yes,
ma'am.
it did happen, and it is possible. I think the patience, the way enzyme takes 90 days for it to make, I think that patience for to show the result at such a large scale definitely we need to
Yes,
wait and
ma'am.
watch, and it works. It works. Uh, the so we will be discussing a lot of these kind of treatment what we can do, but I
Yes, ma'am.
I still wonder, why this has not been accepted so widely.
And that's
But
only, ma'am.
so what I
What
feel,
they
no,
are.
doctor, see
Yes,
now
ma'am.
we are doing our research, we are doing our own thing, but now
Yes,
like
ma'am.
your support is there, Dr. Chandana's support is there, and so I mean scientists should do their work and we should do our work. We should go all out and start, treating or retrieving a lot of good water from the water which is just getting into drains. Uh, we all of us we just have to do our job. So rather than just
Definitely.
putting head yeah,
Actually,
into
we are
everything.
working. After I heard some of the things from you only, I also think it is great, because after my thesis all is over, if I started working on it, so many that is the words which is not useful for me to grow. They will use, this is not way. So it having some pathogens. It will have, so to justify one by one, I have done some of the things, but till we need to do a lot. to get an approval like this.
Yeah.
Yes, ma'am.
So this is
And
good.
even in the name also, as Sarah asked, one of the audience asked that bioenzyme, why it is bioenzyme. So this question is asked by different scientists when I'm approaching for a proposal, funding. Everyone is asking, and they are not thinking it is not only an enzyme; it is also having a microorganism.
Yes.
That's it.
So
So
I
I'm
mean,
just trying to inform them, and I'm justifying with my studies.
yeah,
So if
and I
more
feel we
studies
should
are
just
coming,
work, doctor, and when there is a result and there's high time we start
yes, ma'am.
implementing it at the ground level rather than
Yes, ma'am.
questioning it because it is not harming anything, right?
Yes,
So
ma'am.
we
But
just have
so many
to,
people
mm,
not accepting it because of the
yes.
questioning mind what they are having.
Yeah, so Dr. Roshakon always say, just do it, so just do it and leave it everything else. So, at least you will get some result. We are already into destroying so many things, but let's just do it. It's just whatever, whoever is doing whatever, let them do whatever they want. But along with that, give a chance to enzyme, give chance to bioenzyme and see the result, how it works.
Yes, ma'am.
It works fantastically because I know
Without
whatever,
harming anything.
yes. So everywhere, I mean, if we start using sensibly, I think the results are there. But we should have, I mean, everybody shouldn't put into their head into everything. We just have to do our job and show the result because that is
Yes,
more
ma'am.
important. Working and implementing at ground level is very important part of
Yes, ma'am.
taking the technology from lab to the ground.
From
So
level.
let us do that and let us stop those. And this 31 days, that is what we are trying to do. We are talking about the toxicity in our life, everyday life,
Yes, ma'am.
and how we can, I mean, even if we don't use enzyme, but can we think of something else? Can we think of some other solution? Because these are all part of our life,
Yes, ma'am.
and how much do we keep consuming about around it? So that was the reason. I mean, we thought, okay, let us start talking about it at least, because otherwise, our next generation will get feed on only what is being fed to them. They
Yes,
need to understand each ingredient, how and why, what is the cause of this lifestyle diseases coming up, why this is creating certain issues, So there are ways. So, and our vision is very large. We are working on restoring the soil, we are working on restoring the
yes,
water,
ma'am.
and we also want to restore the air.
Yeah,
So that,
definitely,
you know,
madam.
and
It is working very good also in the air also. Some of the
yeah.
study have reported by some of the people.
Mm.
And we are also working on different applications till it is in a stage of paper completion. Though after completion, we will make it published.
Oh, yes, that will be great because we
Yes,
have
ma'am.
already done the applications in Delhi. And
Yes, ma'am.
if it is get backed with the scientific paper, that would be fantastic.
Yes, ma'am. Definitely.
Thank you, Dr. Arun, for
Thank you,
this
ma'am. Thank you
wonderful
very much for
evening.
all of
And
them.
yeah, and sorry to bother you, though you
No
had
issue,
some
ma'am. No issue, ma'am.
emergency. But anyone has any question, you can ask, or anything you want to discuss, because we don't get chance to discuss scientifically, So we can discuss and any doubt, anything, because everything we can't be done on WhatsApp. So this is your chance to explore and learn.
Dr. Arun, for the wonderful presentation.
Thank you, ma'am.
So the research which you mentioned about the dairy industry waste, so is
Yes,
it
ma'am.
only for that particular industry, your
No,
current,
ma'am. It can be used in versatile of industrial waste, but we are working only on biosludge, and even for landfill leachate also it is working a lot. We have done research on the dairy, so it is published. So I have shown that results and all. That's it. But it is working a lot, and every enzyme has its own application and its degradation also.
Okay. And you also mentioned landfill and leachate. So is it like even for treatment of the landfill odor and all, it's been used? Like if you can share one
Yes, ma'am. It is.
locations where it's
Yes, ma'am. It is working a lot, but it is working only. We have done with this lab scale. Preeti ma'am is doing in a lab scale, and she have experienced a lot in that, and she shared also. It is very good. And after that, so many changes have been changed in the air, which is present in the landfill also.
okay.
Directly, which is studied in Kashmir and Delhi also, I guess.
Okay. Okay. Thank you so much. Thanks for the
Yes, ma'am.
wonderful
Yes, ma'am.
presentation
Yes,
and
ma'am.
sharing.
Thank you so much, Dr. Arun. Just
Thank you
want
so much.
to clarify a little bit more about your research.
Yes,
You had been successful in reducing the mosquito population
yes,
through
sir. Yes,
this
sir.
using, yes.
Yes, sir. Yes, sir.
How can you kindly briefly explain how
Sir,
that happens?
actually,
Thank
a
you.
mosquito repellent means just it will reduce that biting, that sensation which is produced by it. Because when you are going for a 9 month, it is around like vinegar only. So vinegar is a repellent for mosquitoes in general. So, but the concentration of vinegar should be reduced when we are going for applying in our when you are going for liquid based mosquito repellent, then it is UC. It is, you can directly use it, but you want to justify whether how the mechanism, because the mechanism is still in research. We are unable to find how it is replying because of this vinegar activity only, because of the acetic acid which is present in the garbage enzyme plays important role in this, I guess. Because we cannot the mechanism is need to be justified till it is in process. I also working on resistance towards some of the insects, so we are working on it, but till the mechanism of its action on the insect is we want to study a lot, because it
Thank,
needs some entomologist have not done that. So we have we are getting assistance from them, and they are working on it, and till we want to get the result. After getting the result, definitely we will tell the
thank you,
mechanism how it
Doctor.
is working.
Thank you so much,
Yes,
Doctor. Thank you.
yes, sir, yes, sir.
I could see Parul was raising her hand. Parul, you can go ahead.
Yes, yes. First of all, thank you so much, Dr. Arun, not
Thank
only
you,
for
ma'am.
the presentation, but also being consistent with your research, although you have a lot of struggles, I heard. For all those consistency, you become an inspiration for all of us. The second thing I wanted to ask is how can I access your research, publications? Like if I want to read all those things, so is there any link or somewhere I can
So
go and
whatever
read?
I have published, I will share with the Preeti ma'am. You can get it from her. And
Okay.
if you want some of the paper which is not available, you can just mail me lrcarun@gmail.com. If it is an
Okay.
elsewhere based publication, I can able to retrieve it. Others we cannot able to retrieve. If you have any IITs and NIT people, then you can retrieve from them.
Okay. So thank you so much. Thank you so much.
Yes, yes, ma'am.
Dr. Arun, since you mentioned about vinegar, so for a
Yes,
common
ma'am.
person, what is the difference between vinegar and the enzyme? Let's say it's made out of lemon or apple. So how is that different from standard vinegar?
So garbage enzyme is having acetic acid also. It is having organic acids. So acetic acid is the commercially it is called as vinegar. It is that's it. It's an acetic acid. Because of the presence of acetic acid, the finally whatever the matter according to the natural phenomenon, it will convert that into acetic acid. Then it is further degraded by some of the microbes also to produce biogas, biomethane, biohydrogen, etc., etc. That is called as VFA. So in that VFA, acetic acid will be more. That acetic acid is nothing but vinegar.
Okay. So basically,
So
for a common person, we can say that bioenzymes or garbage enzymes are your vinegar plus a lot of other things.
it is having vinegar also. When you are going for a third month, after third month, acetic acid level is higher. So it is having higher amount of we are having VFAs, that is different organic acid. In that organic acid, acetic acid is more, like that you can tell.
Okay, thank you.
Okay,
Yes.
Mr. Vaidya, can you just quickly ask your question?
Yes, ma'am, that's Khayali here.
Okay, yeah, Khayali.
Actually, because of some reasons, I could just join, so I was not able to watch and listen to throughout the lecture. But sir, Preeti ma'am, first of all, thank you to bring the speaker in this seminar, because this is the one whose papers I have read a lot in my PhD year. So I was like so glad to know him, and I am so. And I am, sir, I have
Thank
read your papers and I have
Thank
used
you.
your
Thank you.
reference also in my thesis. So, yeah, I would also love to explore many things. If you can share your email ID, so I can, if you
Yes,
have
ma'am.
some more publications to read, I would be grateful if you can
Yes, ma'am.
share some of those which are retrievable. So,
Okay, ma'am.
yeah.
Okay, definitely I can. So my mail ID is lrcarun@gmail.com. It will be
Sorry,
there
sir.
in the papers also.
Okay, okay.
lrcarun@gmail.com. It will be there in the
Okay, sir.
paper also.
Thank you. Thank you
Yes,
so
ma'am.
much. Thank you.
You are from which college, ma'am?
Sir, I am from Gujarat, Kutch University,
Okay.
Gujarat, Bhuj.
Okay. Okay. Okay.
Yeah.
Okay. Thank you.
Yeah.
Any more questions? Okay. So thank you, Dr. Arun, for sharing
Thank you, ma'am.
your learning and knowledge with us. It's really very enriching, and
So,
we are,
Internet.
yeah. Acha. Rosemary,
Yeah.
Rosemary. Yeah, Rosemary, you can ask. Sir is still there, you can
Hello.
ask.
Thank you for the opportunity. I'm very happy to join this Zoom. Especially there's Dr. Arun. I usually read the paper, very inspiring and useful. I share a video of myself pouring bioenzyme outside my home. Then it went viral on Instagram. Then there is a comment that asked me, there are any negative effect if we pour too much bioenzyme into the environment? Many us worried it may make the soil pH too acidic. That's my question.
No, because it is having organic acids with this, which is not effective. All these are weak acids. So mostly it will be weak acids which is present in garbage enzyme. It is not strong acid like HCl, H2S. So it is a weak acid which will not affect the environment. When goes to environment, it will be diluted and it will be used. It will be used by the microbes for further degradation. So definitely it will not affect.
It's a weak acid. Okay, thank you, doctor.
But when you are going for any application, according to the application, it should be diluted. Then only the optimal value you can able to get. So we should not waste the produced garbage enzyme also. The concentration should be managed.
So, like, is it that there is always a fixed dilution, or like throughout entire my research, I have
No,
always diluted in like 1 or 2 times, or one or 10 times. So, are there any fixed
definitely
dilutions, or
according to the application, it can be diluted. So
okay?
yes. So you want to optimize it according to your application. So in which dilution you are getting more results.
Yeah, that's true. Okay, I understood.
Yes.
Okay, so Thank you, Dr. Arun. Thanks again.
Thank you, ma'am.
Yeah. I hope there is no more questions, but if someone is having any questions, so sir has shared his email. You can always go and write on his email, and I'm sure he'll be happy to answer the questions. So, okay.
Definitely, ma'am.
Yeah, thank you so much. So thanks again. So we listen to both our speakers, both the experts. For some, it may sound very technical. Yeah, for me also, it was very technical. Some couldn't understand the technical terms, but one thing is sure, that is bioenzyme or the enzyme work. So both our experts had done their assessments. They have done the impact assessment, they have done the technical assessment, they have done the environmental assessment, and on all the parameters the bioenzyme has proven itself, or maybe we call them the enzymes have proven itself. So I mean, they have worked on STPs, it worked. They have worked, Dr. Arun has worked on biosludge, it worked. Preeti has worked on STP and on Lechet, it worked. So the takeaway from this whole last two hours is that bioenzyme worked. So I mean, there is one line Dr. Chana has said: bacteria are friends of humans, and truly so. Our own gut has around 100 trillion microorganisms, mainly bacteria. So we are all made with bacteria or the microbes. So actually they are our friends. So let us take this call and decide that whom do you want to make friend, the bacteria or the chemicals. So it's our call to take on this day, and let's take this pledge to use bioenzyme or the natural products as much as we can. As it is said that if you are struggling to manage something, just reduce that thing. So if we are struggling to manage the chemical, so the thing to take care is to reduce that thing. So the load matters. So just try to reduce the chemical load from our homes, our whole ecosystem. So with that note, I ask Ms. Jyoti to, do the vote of thanks.
Thank you, Samira ji. Yeah. So our theme is Let's Beat the Toxins Together. We started this initiative of hosting or programs for World Bioenzyme Day. This is the third year that we are doing it. And it's quite amazing to see the kind of people who have come together, joined hands with us. Today, we had two eminent speakers, Dr. Chandana and Dr. Arun, who have been closely working with Bioenzyme Entrepreneurs Academy. And they are on our panel of advisory, and they have been really, really contributing so much because, as we saw, many of the questions raised by our participants, because as Samira ji also mentioned, majority of the work or the contribution right now was technical, and not many of us are familiar with the technical aspects of bioenzyme. But yes, all of us have started with passion, and we are heading towards the scientific path of it, because one day we have to reason out the scientific effects by bioenzyme to anyone and everyone that we are meeting. So in this note, yes, we have proclaimed 4th January as World Bioenzyme Day, and the event has been always 3 days event, and today being the first day of 2026 BEAT event, I would really like to thank each one of you who have joined us for this event today. Firstly, my gratitude and thanks extended to Dr. Chandana for amazingly taking us through the sludge management that she has been doing and coming out with her paper. We are really awaiting for her technical paper to be published, and which will be available for all of us to use it. Again, Dr. Arun, he is not a new person. He's been part of Bioenzyme Entrepreneurs Academy and doing amazing work. So it's always a strength to have like-minded people, especially the ones who are into research and studies with us. So it really, really adds value to the work that we have been doing. So my heartfelt thanks and gratitude to both Dr. Chandana and Dr. Arun. Thank you for your valuable time and valuable sharing. We are going to take this forward in larger ways. We did have people mentioning that they're going to go through your research and see how best they will be able to use it. Thank you. Thank you once again. And yes, so to all our participants who have joined, thank you. Many of them have joined from many parts of the country and abroad as well. So thank you very much, even without thinking twice, that you have joined with time zones also being different. Thank you once again. Please do continue to be patrons. Join us tomorrow and day after so that we will come in large numbers and ensure that we are here and show our solidarity. Thank you, everyone. And I would really fail if I don't thank to our entire team of BA and our well-wishers. I would like to extend my gratitude and thanks to everyone on behalf of the trustees. We have our volunteers, we have our members who have been really supportive and who have been working tirelessly for the last 1 month and setting up all the aspects for the event, which is a curtain raiser today. So thank you very much, everybody. The technical team who's really handling all the aspects of the Zoom and the videos and voice, etc. So here I would like to make a special note of thanks to Ms. Likita, who has been quite at the back end and supporting us. Thank you, Likita. Samira ji, thank you very much for moderating this, the entire program for the last 2 hours and summarizing the event. It was really amazing to have you. Preeti, thank you so much for your inaugural address and being there like a pillar, holding all of us together. Thank you, Preeti. Sucheta Sahuji, yes, thank you for opening the event with your Shanti Pat. So it's amazing to have all of you all. We are looking forward to all of you joining us again tomorrow between 3 to 5 p.m. and on the 4th, 3 to 5 p.m. 4th, we will also be celebrating Dr. Rushikon's birthday, and she will be addressing us as well. So we have eminent people joining us. Do not fail. I know you have really taken your time off. Continue to do that tomorrow and day after. Thank you, everyone. But before we sign off, I would like to invite our friend to take us through the pledge. Thank you so much.
Thank you, Jyoti.
Good evening, all of you. I pledge to embrace and promote the use of bioenzymes to protect our soil, air, and water. I commit to making and using bioenzyme for organic waste management, reducing chemical pollutants, and fostering sustainable ecosystems. Together, we'll safeguard our environment and create a cleaner, healthier world for all. Thank you.
Thank you, Ruchi.
Thank you.
And with this note, let's say happy Bioenzyme Day to each other, and let's keep exploring the potential of Bioenzyme. Now we have our research partners with us, so keep exploring and give a good data and good research topics to the research brains, Dr. Chandana and Dr. Arun. So with this note, thank you everyone. Thank you for joining. Good night, and again a very happy Bioenzyme Day.
May I request all of us to kindly turn on our videos so we can just quickly have a glimpse and take a snapshot. So it is going to we will be creating memory out of it. Thank you.